Welcome to Chemical Change versus Physical Change, Part 2. I'm Mr. Meyer, and we just did 3 reactions that were chemical changes because we created new materials which were formed with new properties. Okay, we had changed the identity of substances, and essentially old bonds broke and new bonds formed. I'm just going to grab something here, a little marker, and spotlight a few things. I'm going to go down to the last reaction we did. We took hydrogen gas that we had created from the reaction before, combined it with oxygen in the air, and sparked it. The hydrogens travel in pairs, the oxygens travel in pairs, but we broke those hydrogen bonds, we broke those oxygen bonds, and now the oxygen and hydrogen can form H2O. Old bonds break, new bonds form. Okay, in the reaction before, we took zinc solid, combined it with hydrochloric acid, and notice the hydrochloric acid was attached together, but the zinc came in and kicked the hydrogen out. Now the hydrogen formed a gas and it was all by itself, and now the zinc was with the chloride. Old bonds broke, new bonds formed. This first reaction where we formed the red solid or precipitate, we had sodium connected to this chromate ion, CrO4, and silver connected to the NO3, and they switched places. The Na connected to the NO3, and the Ag connected to the CrO4. Now there's some balancing and other things we needed to do with balancing of chemical equations, and that will be something we'll do down the road. But it's a chemical change because old bonds broke, new bonds formed. There are some visual clues that we get for a chemical reaction occurring. And one of them is a color change. In this first reaction, this was yellow solution, this was a clear solution, and this was actually a red solute. It turned red, so that was a color change. We also saw when it settled, it actually got chunky and it formed a solid. So this is another one of the things, formation of a solid precipitate from 2 solutions, which was formed right here. In this next reaction, the zinc combined with the hydrochloric acid, it bubbled. That was an indicator of this hydrogen gas. So formation of a gas would be an example of something that shows maybe there's a chemical reaction. This also got quite a bit warmer. That significant temperature change, usually getting warmer, but not always, would be a sign of a chemical reaction. And then this final reaction, yes, it did get warmer when I combined the hydrogen and oxygen and exploded it, forming water vapor. And you also saw the bright light or the emission of light, which would be another thing right there. I'm just going to head back for a second and look at this right here. And let's see if I can scroll up. Here we go. And physical changes, and just do a little comparison. Physical changes do not involve changing the identity of the substance. In other words, there's no bonds are breaking or forming. So we talk about cutting something, which would really just be splitting it at the atomic level. We're not splitting the atom, we're just separating atoms. Dyeing something, dissolving something would all be physical changes. And then all of our phase changes, evaporating, freezing, melting, condensation, sublimation, deposition, are all phase changes and are all physical changes. For example, if H2O liquid evaporates or vaporizes to H2O gas, the molecules of H2O are intact here, they're intact here. What happens is we separate the molecules from each other when we go to a gas, but there's still, the molecules are intact, so it's not a chemical change. Sometimes these changes for chemical change can be misleading, so you have to be careful with them. If I took a blue dyed solution and a yellow dyed solution, I could mix them and get a green dyed solution. That's not a distinct color change. There, I'd probably think it was a physical change. Let's say I froze water into ice. It would be the formation of a solid. Now it's coming from 2 solutions, but just be careful. If you see a formation of a solid, it's not necessarily a chemical change. Formation of a gas. Again, if I boil water, it bubbles. That's a phase change right here, but it's not the creation of a new gas. So yes, these are good indicators of a chemical change, but you have to explore deeper. And again, when old bonds break, new bonds form. That's chemical change. When you don't have the breaking of bonds, then that is a physical change. Thank you.